It's a little more than just 3 this time.
Okay, cool.
Okay.
You can verbalize them, I'll write them, and then we'll both solve them. Hopefully you'll solve them.
So, yeah, right now we're working on y equals 3bx minus 7x. I mean, we're working on literal equations.
Okay.
And our first one is y equals 3bx minus 7x.
Like that?
Yeah.
Okay.
So what we're going,
And what's the question?
we have to get x, we have to solve for x.
Yeah, solve for x, right?
Yeah. So first we're going to put in parentheses, so it's going to be y equals x, and then in parentheses, 3b minus 7.
Okay, so we've factored out an x is what we did.
Yeah, and then we divide 3b minus 7 by 3b minus 7, and it's going to be, yeah, equals x.
There's your answer.
Mm-hmm.
Okay, cool.
So the next is sx plus tx equals r.
Again, solve for x.
Yeah, solve for x. So then we're going to do in parentheses, s plus t equals r.
Not quite.
S plus t equals r times x.
Well,
I mean, s plus t, in parentheses, s plus t, and then out parentheses, x equals r.
It's important to write it like this.
Oh.
Only because I want you to think about it like that. In other words, when you see this problem, your first thought should be greatest common factor. Can I take a greatest common factor out of those two terms? And the answer is yes, you can take an x out. And what does that leave behind? S plus t. Notice that if I multiply those two back together, I get what I started with. Okay? The only reason I'm saying that it's important as to what order you write it in is because I want you to think about it like this. I want you to always think that you're factoring out an x. Okay? And then finally, x is equal to what?
S is equal to r divided by 5 plus t.
S plus t?
Yeah.
Okay. And that's the way you do it. In other words, you don't really care whether that s plus t is in front of the x or behind the x. It's the same thing. But the process of factoring is the important process here. And that usually begins by figuring out what's the greatest common factor. In other words, I'm looking at that expression and I'm trying to figure out what the greatest common factor is. Well, it's x. So the very first thing I do is I take out an x. And then I divide both terms by the x to figure out what's left. And that's s plus t. All right, what else?
4x plus 5bx equals 24.
4x plus what?
5bx.
Okay.
So first we're going to do x equals 4 plus 5b and then equals 24.
X times, we're going to factor out an x. Now what's x?
X equals 24 divided by 4 plus b. 4 plus 5b.
There you go. Okay.
Next one is a equals bx plus cx equals plus d, I mean.
A equals bx.
Bx.
Like that?
Then we're going to write a equals x, and then parentheses b plus c plus t. Plus d, I mean.
Notice that that's a little easier if I move the d over first. well, let's back up one. If I'm going to take the approach here that I'm going to gather all like terms, and like terms are terms that have x in them. So I'm going to gather those on one side of the equation and everything else on the other. So my first step would be more likely to be that. There's nothing wrong with the way you did it. It's just a question of taste. But I like to gather all my like variables. Now I get a minus d equals what?
A minus D equals, oh God, I don't really,
What are you doing to that?
factoring.
Okay, what are you going to factor out? A greatest common factor.
X,
Okay, what's left?
B plus C.
Now what's the answer?
X equals B plus C minus D.
No.
I mean,
In other words, here's what we have.
A minus D, sorry. A minus D over B plus C.
There you go.
Okay, so the next one is the total cost C in dollars to participate in a ski club is given by the literal equation C equals 85x plus 60, where x is the number of ski trips you take.
X is the number of what?
Ski trips you take.
Speed trips?
Ski, S-K-I.
Okay. Okay. So in other words, if you go skiing once, your cost is $145. If you go skiing twice, it's 170 plus 60, so 230. So that's what they're talking about. Okay, so now what's the rest of the question?
That's it. Solve the equation for x.
Okay, let's solve it for x.
So then we're going to do in parentheses C not in parentheses, C equals x, and then in parentheses 85 plus 60.
Hold on. Let's back up. If we're solving for x, then the first thing we want to do is get rid of that. The next thing we want to do is get rid of that, in that order. Okay? How do we get rid of the 60?
Subtract.
So I got C minus 60 equals 85x. Now how do I get rid of the 85?
Divide.
So that's x. Now, is that all they wanted for this problem? They wanted you to solve for x in terms of C?
And then we do, how many ski trips do you take if you spend a total of $315 and then 485?
So 315 and 485. So how do we solve for x?
We're going to be doing, x is,
In other words, we've come up with an
equation.
So. Yeah, we've come up with an equation that defines x as a function of cost, and here's the two costs.
It's going to be 315 minus 60 divided by 85 equals x.
So
and then it's going to be
15 minus 60 sounds like 255 divided by 85 equals x. That would equal 3. So if your total cost is $315, you took 3 ski trips. Now if your total cost is $485, how many ski trips did you take?
You did it way faster than me.
A plus math.
425 divided by 85.
Now, what do you know about the answer? I mean, I know you have a calculator.
Gonna be 5.
Yeah, what you know about the answer is it's a whole number, right?
Yeah.
Don't you know that? In other words, it can't be 4.5 or 5.5.
Yeah, it has to be.
We're talking ski trips here, so there's no such thing as a half of a trip or 9/10 of a trip. So you know that has to be a whole number. Well, 8 goes into 42 5 times. It's 5 or nothing. So there's shortcuts you can take in doing the arithmetic on some problems, like this, where you know the answer has to be a whole number. It's easy to divide 255 by 85 when you know that it has to be a whole number. All right.
Okay, so now we have another one like that.
Okay.
The penny size of a nail indicates that the length of a nail indicates the length of a nail. The penny size d is given by the literal equation d equals 4n minus 2, where n is the length in inches of the nail. Solve the equation for n. First we're going to be doing d equals n, and then in parentheses 4 minus 2.
No, you can't factor that out. You don't want to factor that out.
Oh, yeah, so then we do, sorry, we do plus 2, and then divided by 4.
Okay.
I keep forgetting.
Always remember that if it's already solved for d, you're not solving for d, you're solving for the other variable, the one that isn't solved for, n. Okay, so now we have an equation for n, the length of the nail. And so they're going to give you various d's and want you to come up with the n. What's the first d?
3, 6, and 10. So it's going to be 3. Find the length of the nail when the following penny size is 3, 6, and 10. So,
okay.
So it's going to be
3.
3 equals 4n minus 2.
Hold on. I'm going to substitute 3 for d, right?
Yeah, I did. 3 equals 4n minus 2.
Well, remember we're solving for n.
Yeah, but I'm just adding, I'm just replacing the d.
Back. What you're doing is going back to the original equation.
Oh, yeah, sorry.
We're trying to solve for n, not d. They're giving us...
Sorry.
No problem.
3 plus 2 divided by 4 equals n.
Okay, so that's the n we get when d equals 3. What n do we get when d equals 6?
We get, it's going to be 6, 2, n equals 2.
And how about when it's 10?
It's going to be 4.
It's 12 divided by 4. 3.
Yeah, sorry.
It's all right.
12 divided by 4.
We'll put in our time on A+ before we are finished today. So now, in this case, the length of n in inches doesn't have to be a whole number. So 5/4 is perfectly reasonable. That's 1 1/4 inches. 2 inches is reasonable, 3 inches is reasonable. But it's not like the last problem that was the number of ski trips. That has to be a whole number. So if you get a fractional number when you're solving a problem like that, it probably means you made a mistake. And that's important. It's important to have flags that alert you to the fact that, well, maybe I made a mistake and I need to go back and do the math over again.
Mm-hmm.
So it's important to know whether your answer should be an integer or not. In this case, it does not need to be an integer. All right, what else you got?
For problems 16 through 19, solve the formula for the indicated variable.
Okay.
Profit P equals R minus C, solve for C.
What's C equal to?
It's going to be, 1 second. Sorry.
What's the easiest thing to do here to get
Minus R, C plus P, C minus P equals C. C minus R equals C. P minus R. God, sorry.
Actually, here's the process we want to go through. It's easy to get confused because here's the problem. There's a negative sign in front of that. So if I merely move the R over, then I've got P minus R, but it's equal to minus C. They want to solve for C. So it's better if I move the C over, because that changes its sign to a positive immediately, and now I'll move the P to the right. So that's what C is.
So C equals R minus P.
Correct.
Okay.
Now, let's go back a second, because this is important, I think. If I do it the way that a person would be inclined to do it, move the R over immediately. Okay. Now I can get rid of that negative sign by dividing by -1. And now I get C all by itself, and this is always the reverse. It's always R minus P. In other words, here's what I'm saying. This is a good thing to know. A minus B is always the negative of B minus A. No matter what A and B are, the statement is always true, which means that A minus B divided by B minus A is always -1. Or, see what I have circled over here? If I take a P minus R and divide it by -1, it instantly turns it into an R minus P. So that's one way. Remember, there's always tons of ways to do these problems. The way that I'm favoring is to get the C by itself with a positive sign in front of it instantly. In other words, I'm going to take the C and I'm going to move it to that side there, and I'm going to take the P and move it to that side there, and that gives me a positive C equals R minus P immediately.
So I have two more.
Okay.
2 plus 1 over 6y equals 3x plus 4.
Is it 1 over 6y, or is the y in?
Yeah, 1/6y. That's it. Equals 3x plus 4.
Equals 3 what?
X plus 4.
Solving for y? Solving for y?
Yeah.
Okay. Couple of first steps. What would your recommended first step be?
I don't know which way I would want to get it over.
Well, we're trying to isolate the y. We want our final step to be that.
But I don't know which side I want the y to be on. That would be the
easiest. Doesn't matter. But it's on the left side, so let's leave it there. It's on the left side.
Okay, fine. Then subtract 2. Okay. Subtract 2 from both sides.
The first step is to get rid of the 2. Gives us what over here?
3x plus 2.
Okay. Now, what's the last step? We only have to do one more thing to get rid.
Divide by all of this by 1/6.
Did you say divide or multiply?
Divide both sides.
Okay. Dividing by 1/6 is the same as multiplying by 6. So I'm inclined not to think in terms of dividing by fractions, but multiplying by that. Okay?
Okay.
If I multiply the left side, I'm going to multiply the right side. Well, those
Mm-hmm.
6's now cancel, leaving me with y all by itself, which is what I want. What's the right side?
Mm-hmm. It's going to be
Distribute that 6 to both.
18x plus 12.
Okay. And there's your answer. Now, we had a couple of options. Normally, I tell people, let's get rid of parentheses and denominators. So I have no problem with the technique that says, let's start out by multiplying everything by 6. So that gives me 12 plus y equals 18x plus 24. Now I move the 12 over, and I instantly get my answer. But notice I had to deal with some big numbers here. 24. I didn't deal with a number as big as 24 before. So the more favorable way to do these is, rather than to get rid of the denominators first, let's get rid of the whole numbers that are added or subtracted to that side of the equation first. Might make the problem easier. What else you got?
11 minus 1/2 y equals 3 plus 6x.
First step.
Subtract 11 from both sides.
What's the
So
next?
it's going to
What's the next?
negative 1/2 y equals negative 8 plus 6x.
Now what do we want to do?
Multiply both sides by -2.
Good. What's that leave you on the left?
It's going to leave us y equals
Leaves y.
negative.
That's the key.
Y,
That's
yeah.
why we multiplied by -2. Was so
Yeah, y
with just y. What about
y equals 16 plus, minus 12x.
Good. Okay. What else?
Okay, sorry. Then we have another solver. So it's going to be surface area of a cylinder. S equals 2 pi r squared plus 2 pi r h. Solve for h.
Okay. How do we isolate h all by itself?
It's not SA. It's just S.
Okay.
So first we have to go S equals.
We're trying to solve for h. So
Yeah, S equals 8.
let's start with that side of the equation, getting rid of everything that's with that.
Well, I'm doing that. S equals h, and then in parentheses, 2 times pi times r squared plus 2 times pi times r.
Okay. If I'm trying to solve for h, that does not have any h's in it. So the first thing I'm going to do is get rid of that. Subtract it all.
Okay.
Okay, see what I'm doing? I'm just gradually trying to narrow this down so that I end up with h over here. And what final step will give me h?
Divide both sides by 2 pi r.
Right, 2 pi r. So that's equal to h. And it's important to know that when you're solving equations for a variable, you can't have that variable on the other side of the equation. You haven't solved for it. In other words, if I say h equals 3 minus h over 2, I have not solved for h, because I got an h on the right side of the equation also. So the only time it's correct to say that you've solved an equation for a variable is when that's the only place you find it, is on that side of the equation. It's all by itself, and there's no h's anywhere else. Okay? Now, let me make this problem a little harder. Solve it for r instead.
Then I'm going to do
Your first step now.
s equals r, and then in parentheses.
Okay, you're going to
Because
factor the r.
both sides have it. S equals r, and then parentheses 2r squared plus 2 pi rh.
Hold on. To make sure you do this right, when you factor out an r and you write what's left, before I write anything else, I've multiplied that back together again to make sure I got that. And I do. Now, let's put the rest of it.
No r's, and it's instead of an r, it will be squared 2 pi squared.
Right. Okay. Now,
there's an r in the parentheses.
I can't solve for r.
There's an r in the parentheses.
Exactly. So if I try dividing both sides by that, I'm going to get r on the right side, but I'm going to have an r on the left side also.
Oh.
So this is, you can't solve for r here the way you were able to solve for h. H you could solve for because there was only one h in that whole thing. Whereas r, not so easy. There's an r squared and an r, and you can't do much with that. Solving for r here kind of brings in quadratics and the quadratic formula stuff. All right. You have any more?
Yeah, I have a bunch more.
Okay.
I actually only have 4 more.
Okay.
But, so, I have a equals 1/2 h, and then parentheses, b1 plus b2. The 1 and the 2 are at the bottom of the equation, like under the b.
Subscripts.
Yeah.
That is the formula for the area of a trapezoid. In other words, trapezoid is like a rectangle, only it has 2 different bases. There's base 1.
Base 1 and base 2.
2, and they mean vertical height. So if I want the area of that trapezoid, that's the formula I'm going to use.
We have to solve for base 2.
Okay?
So first I have to take out the parentheses.
Good. Hold on. So you get a equals what?
I have really no clue.
When you're getting rid of parentheses, what you're doing is you're multiplying this 1/2 h times each term that is in the parentheses. So
okay,
if I multiply it by the b1, I get 1/2 h b1. When I multiply it by the b2, I get 1/2 h b sub 2. Okay? Now, again, I'm trying to isolate that. And it's okay if I have a b1 on the other side of the equation. I can have b1, I just can't have any b2s. I haven't solved for b2. So what's the next step?
It's going to be easier if we get the b2 over to the left side. So we're going to,
Not really. It's not really
oh,
going to make it easier. It's actually going to make it harder. Because in order to get the B2 to the left side, I'm going to have to introduce a negative coefficient. Then I'm going to have to deal with negative numbers. So don't concern yourself as to which side of the equation the variable is on.
so then we add,
Just as good as right side, or I should say.
so then we add 1/2 HB
I'm
on both
going
sides.
to move that to the other side immediately.
Yeah.
So I got to subtract
So,
1
oh yeah, so it's going to be A
HB
equals negative A minus
right?
1/2 HB1
Okay.
equals 1/2 HB.
Now, what's a good next step?
To divide both sides by 1/2 H.
Yeah, or multiply both sides by 2 and divide both sides by H.
Okay.
Well, I want you to start thinking that when you have a fraction here, you're not dividing by 1/2, you're multiplying by 2. They're the same stuff. They're the same exact thing. But thinking about it as multiplying, because what's it doing right now is we're dividing by 2. That's what we're doing. That's not what this 2 subscript means, incidentally. But this 1/2 means we're dividing by 2. So let's multiply 2. If we multiply everything by 2,
We'll get 2A minus negative 1 minus 1
see how I got that line?
minus 1/2.
Because all I did was multiply every term on both sides of the equation by 2.
Mm-hmm.
Okay, now what's the final step?
Divide by H.
Yeah, that's all you do. That's all solving equations is about, is getting rid of everything that's attached to what you're trying to solve. In other words, originally we had that attached and we had that attached. So let's get rid of the thing that was being added, first of all, and then let's get rid of the thing that was being multiplied. So that's how you want to think about solving equations. You find your variable, you know what the last step needs to be, and then you just get rid of everything else. But you have to do this in multiple steps. In other words, you have to distribute before you can do it. You know what? No, you don't. I just realized I did not do this in the simplest way. Let's go back here a second. What if we start out by multiplying both sides by 2h? Well, now that gives me 2AH equals B1 plus B2. And they want you to solve for B2?
So we subtract B1. 2AH minus B1 equals B2.
How much simpler that was. Is it the same answer?
Yeah.
I made a mistake here. I meant to divide by H. I meant to divide by H. It's still a simpler way. It's not the same answer, the way I did it, because I made a mistake. Here, let me...
Yeah, it would be
let me go.
2A minus HB1.
Here we go. Let's do it properly here. First step is to multiply everything by 2. Second step, divide everything by H. Third step, subtract B1. So you get 2A over H minus B1 equals B2, and that is the same as what we got doing it the harder way. They are the same. In other words, you can take this lower answer, split it into two fractions, and you get 2a over h minus b1. By that I mean a plus b divided by c can always be split into this. Okay?
Mm-hmm.
All right. What else?
Average acceleration of an object A equals v1 minus v0 divided by t. Solve for v1.
v0 divided by t?
Yeah, divided by t.
Like
No, both are divided by.
they're both divided by?
Yeah.
Like that? And what
Yeah.
are we solving for?
v1.
Okay, what's the first step?
We have to add v1.
Let's
add
plan on
v1
ending
and
up with
v0 on both sides.
up with v1 on the right side. I'm going to finish this problem.
Yeah.
Yes.
Yeah, so add v0. Sorry.
I got to get rid of the t and I got to get rid of the v sub 0. Which one do I get rid of first?
v0.
No.
Okay, then you multiply t.
In other words, v0 is also being divided by t at the moment. So it's not so easy to get rid of v0 as my first step. I can't just add a v0 to both sides. But I can get rid of what is dividing both terms, which is t. And that's the other thing, is you have to figure out which to get rid of first. But I can certainly get rid of the t rather easily. And that didn't change the right side by very much, left me with that. Now what's v1 equal to?
A times t plus v0.
Okay.
Now I have two more. A common statistics used in professional football is the quarterback rating. This rating is made up of four major factors. One factor is completion rating given by the formula. R equals 5, and then parentheses C over A minus 0.3.
Like that?
No, instead of A, it's C over A. Then that's the end of the fraction, and then it's subtract 0.3.
Okay.
But they're still in the parentheses, the 0.3.
Okay. Incidentally, I never write the leading zero. Unnecessary. That is the same as that. I waste the time writing a zero. In other words, and they're both the same as this. But I don't write that zero either. And that's the same as this. In other words, if I wanted to write unnecessary zeros, I could write all kinds of them. So my general rule, and they won't necessarily do this in your class, most of the time they'll always give you that leading zero. I have never understood why. But just so you know, when I write it, I don't write the leading zero that's on the left side of the decimal. Okay? And what's the problem here? To solve for A?
We are going to, where C is the number of completed passes and A is the number of attempted passes. Solve the formula for C.
Okay. So we don't really care what these things are. I don't even care that C is the number of completed passes or A is the attempted passes. I just have an algebra equation here that I want to solve for C. Okay, what's the first thing I can do? In other words, lots of things affecting that C. We got something.
Multiply 5 by everything in the parentheses.
I could do that, but you're going to see that it's easier to get rid of that 5 by dividing both sides by 5. Watch. That removes the need for me to distribute it. You see that?
Mm-hmm.
If I were to distribute it first, then I would have a 5c over a minus 1.5. In other words, I would already have a different fraction. So it's easier to treat that multiplier by getting rid of it immediately. Now, what's the next thing I can get rid of immediately?
Add 0.3.
And finally, the last step to solve for c.
1 second. Equal. Divide by, multiply by a, both sides.
Right. Multiply that side by a, and that gets rid of the a in the denominator, and you've solved for c. There's no c's over here. That's the solution. And that's the easiest way to do it. The harder way, it still works, but the harder way is to distribute that 5 first. It just makes it a little more complicated. So the secret with all of these equations is figuring out the order that you're going to use to get rid of everything. In other words, if I'm trying to solve for c, I got to get rid of the 5, I got to get rid of the a, and I got to get rid of that. So the question is, what order can I do it? Well, I can't move the 0.3 over yet because it's being multiplied by the 5. But I can't move the 5 over immediately. Then I can get rid of the 0.3, then I can get rid of the a. So the order that you do these is very important.
Mm-hmm.
Got another one?
Yeah, just one more. The density d of a substance is given by the formula d equals m divided by v, where m is its mass and v is its volume. Solve the formula for m. And there's a picture on the right that says density 5.01 grams / centimeters cubed, and then volume 1.2 centimeters cubed.
Okay. Let's first of all solve this algebraic equation for m.
Oh yeah, that's what they first said.
Right.
Sorry. D divided by m equals, d divided by v equals m.
How do you get rid of the v?
D times v equals m.
Remember, you're always doing the opposite of what it is doing currently. Currently, v is dividing into m. So we want to make sure we multiply by v.
So
now we have a new equation.
It's going to be 5.
Density, what's your density equal to?
5.01.
And what's your v equal to?
1.2.
Multiply those two together and you have the mass. If you're going to start having problems like this, you do need to have your calculator with you when you...
Okay. I don't have my calculator, but I have my phone.
Okay. Well, the thing is that nobody expects you to be able to do that by hand. That's a calculator question.
6.012 equals m.
Okay.
And that's it.
All right. Gives us just a few minutes. Go A++. Rather, A plus math. I want you to start thinking about speed as well as accuracy.
Oh, sorry. That's going to be -6. 10. 7. Negative 4. Negative 1. Negative 12. Negative 10.
Know that it's a whole number. They're not going to give it to you. Even though it's 2 digits divided by 2 digits, you know the answer is going to have to be a whole number, right?
Yeah.
What is it? It's either 5, 6, or 7. Which is it?
7.
6.
No, it's 6. Sorry.
Positive also.
Yeah. 15. Um, 13. Negative 13.
Right. When you see a problem like this, the way I'd kind of like you to see it is minus
Plus
5
negative.
plus
Negative 8.
And that's
how
the same
I
problem as this. Negative 5 plus negative 8. It's just easier on the brain if you see it as negative 5 plus a negative 8.
12.
Whoops. I typed it in wrong.
Negative 12.
11.
11, I mean. Sorry.
Always know when you're adding an even and an odd, you got to be odd. So 6 and 5 cannot come up to be an even number because one is even, one is odd.
It's a negative 4.
This one?
It's going to be 2. Yeah. 2. I know, sorry, I thought you were saying 6 and 5, so I was like, oh, no, it's a negative.
The previous problem, you were talking about that one. Okay.
Negative 5. Negative 11.
If that was a plus sign instead of a subtraction sign, what would it be, the answer?
Sorry, I just saw it as a plus negative. It would be, 3. Negative 3.
Negative 3. In other words, these two plus signs make it minus 7 plus 4. Well, minus 7 plus 4, you subtract the two numbers and you stick a sign on it that's the bigger number. So you're always going to get negative 3. 120 plus 12.
132. 132. Negative 132.
Or positive. 132. Exactly. Now this is the negative plus another negative.
7. Negative 7. Negative 10. 1. Negative 1. Negative 14.
You're definitely getting better at these.
Negative 10.
Oh, I shouldn't have said anything, huh?
No, I mean negative 11. Sorry.
Again, I have an even number and an odd number that I'm basically adding, right?
I saw
when I add an odd and even, I've got to get an odd.
Sorry, I saw 1.
Okay.
Negative 80. Negative 8. Just 8. One. Negative 4.
All right, that's good enough. That's pretty good. I pushed on that once, didn't I?
Yeah, it's an add.
Wasn't what I thought it was, no.
Yeah.
All right, that's good. No, you're definitely getting better at those. You need to take that skill and be able to translate it, though, when you're working with equations. In other words, that's all you're doing when you have equations, is you're doing single digits by you're either subtracting positives or negatives or multiplying or dividing. That's it. So if you're perfect with your arithmetic, solving equations is not going to be any problem at all. All right, I'm going to let you go.
Okay.
And you have a good week, and I will talk to you next week.
Okay.
All right, Logan. Bye-bye.